they come from, and the factors that influence their production and how they can be mitigated. His research interests lie in greenhouse gas and ammonia emissions from manure management for the development of sustainable farming systems. So over to you, Sean.
Lovely. Thanks so much, Tony. I'll just start sharing my screen now. Yeah, so hi, how's it going, everyone? Yeah, as Tony kind of mentioned there, my kind of expertise is more in manure management, in the manure management chain. So hopefully you'll bear with me when I'm talking about synthetic fertilizers. I may not be able to answer all your questions into the specifics, but I'll try and go over them as much as I can. Today is more about the methods, really. It's more about integrated horizontal flux and wind tunnels. So it'll be a case study of comparing both methods when we're kind of tested multiple synthetic fertilizers, which I'll get into. So just put into perspective, if we use cattle as a kind of a proxy for agricultural activity in Ireland, which is a fairly good proxy. You know, we have quite a lot of cattle. We're a pasture-based system in Ireland. We have about 5 or 6 times more cattle than pigs. You can see that the majority of the kind of cattle or the agricultural activity is kind of in this kind of north part in Monaghan, in Cavan, and also down south in around Kilkenny, Cork, Tipperary, and Limerick are kind of here as well. And this kind of pairs fairly well with kind of the ammonia emissions in Ireland as well. These are kind of modeled ammonia emissions from our one of our inventory partners. And again, up around this kind of north area as well, Cavan, Monaghan, where we have quite a lot of cattle and pigs and poultry. This is where we have a majority of our ammonia emissions. And then down again south, we have quite a lot of ammonia emissions as well. So it pairs fairly well up with that. So yeah, thankfully in Ireland now we are currently in our emissions are below the 5% target for the NEC directive, which is really, really nice. So we're kind of over here in 2023. The inventory is on an N-2 category right now. So yeah, what we kind of see from this graph is kind of this whole concept of cross-competing policies where we have the cap quota kind of being lifted in 2015. So we kind of get an explosion of cattle numbers from 2015 to 2018. We get an increase in ammonia emissions. And then from here on out, we start to get a reduction in ammonia emissions after this. And yeah, the kind of key findings from the inventory then. So we reduced our emissions by 6%. And this was driven by kind of a big adoption of low emission slurry spreading. So in Ireland beforehand, kind of broadcast or splash plate was a huge thing for us. So actually moving over to band spreading or trailing hose, trailing shoe was really big. And also reduced fertilizer use. We reduced fertilizer use by 18.2% in 2023. We're not expecting that to be a kind of an ongoing kind of trend, especially into 2024 and 2025, but it was still good to see. So kind of moving on to the ammonia methods, kind of going straight into it. You know, there's quite a lot of ammonia loss drivers, kind of soil pH and type, temperature, fertilizer type, wind speed and rainfall. A lot of these have been covered before. And the methods that we kind of use to measure ammonia, they can either be direct, IHF or integrated horizontal flux, wind tunnels, and dynamic chambers. And we also have indirect methods, soil nitrogen budgets, 59 tracers. But today the focus will be firmly on integrated horizontal flux and wind tunnels. So when we come to integrated horizontal flux, for those who don't know, it's a micromet method. So it measures, again, the horizontal flux of ammonia when fertilizers spread on the land. And in Teagasc anyway, we use a lot of wet chemistry methods. We're have an upgrade to a lot of the kind of fast-paced world today. So we use the looning method or the shuttle method. And kind of they're separated by heights, and based on the height and the amount of ammonia that they catch, we can calculate the horizontal flux from this. So what are the advantages and kind of limitations of this method? Obviously, this is very minimal disturbance of the land. So this is a kind of a picture of when we spread slurry back in 2022. So you can see that the kind of mast is right in the center. There's about 0.25 hectares in diameter. And it's very good for regional emission factors because of this minimal environmental disturbance. We're not going to affect temperature or rainfall or wind speed. But obviously the limitations are the staff hours needed for this method are quite high, especially with the learning method or the shuttle method. The space required is also very high, and because the space is high, and because the staff hours required is high, multiple treatment comparisons is actually quite difficult. You know, we do struggle to have kind of 6 or 7 masts up at a time, which limits inter treatment comparisons. Next, then we have wind tunnels. So it's an enclosure method. So it's a forced airflow method. And essentially what we're doing here is we're measuring the difference in inlet and outlet concentrations. So these are wind tunnels here. We have 18 of them. We recently acquired them, so we're kind of still kind of perfecting the technique from our end. But they're very common for fertilizer comparison trials. So again, similar to IHF, what are the advantages and limitations of this technique? Obviously, for this, certainly treatment comparisons are much better. You can have increased replicates on smaller plots. And also recently then back in 2022 we're now getting papers with online systems that enable high resolution of ammonia techniques with these. And again, just with this, we're kind of using a wet chemistry method, so quite a lot. So in the control boxes over here on the right hand side, there's acid bubblers in them, and we sample them out periodically then. And then with the limitations of this technique, you're obviously producing an artificial environment. We do try and move these as much as possible during the experiment, but you are invariably going to affect the environment. You're going to create artificial airflow. Obviously, the temperature is probably going to be increased, and the precipitation is not going to be natural as well. So typically in papers and research, we get over or underestimations compared to IHF, which would be the kind of closest thing to a gold standard we have when it comes to ammonia emission research. So again, just to make sure that we all kind of know how a wind tunnel works, because I found it the first time when I saw a wind tunnel, I was like, oh, that's kind of a weird technique. So if we have clean ambient air on the right-hand side, and we have an active sampler on the right-hand side as well. See if my mouse is working? Yeah. So the clean air will kind of move through the canopy, and as it moves through the canopy and the ammonia emissions are kind of being emitted from the bottom, it kind of moves through, it picks up more and more ammonia, passes by both the inlet and the outlet samplers, and then is kind of blown out. And because it's being pulled through rather than pushed through, it's meant to create a more laminar flow rather than going the opposite way, and it's more the air would become more turbulent. So this is kind of just a brief little summary of a lot of them. So with IHF, you're going to have larger plots. The environmental manipulation is going to be much less compared to the wind tunnels, but relative comparisons are much more challenging. The absolute accuracy is much higher, and that's why it's better for inventories for IHF. And the setup and sampling complexity is quite a lot higher for IHF as well. And people have trying to get around this with the Z-inst method for IHF in relation to sampling complexity. But we're not going to touch on that today. So just in relation to the trial then that we did in Teagasc in 2023 and 2024, it was on a project called LabMac, or Lab Marginal Abatement and Cost Curve. We love Macs in Ireland. We're producing a few of them now. And basically the aim of the project is to produce or to improve emission factors for our national inventory, both from synthetic fertilizers, but also for manures as well. And the goal of this research today that I'll be showing you is kind of comparing the IHF with our wind tunnels, and we're kind of using IHF as the benchmark. So the fertilizers tested with the IHF method, we tested urea and 2 compound fertilizers, so NPK 27 and also NPK 18. and compound fertilizers are becoming more popular in Ireland. Especially with the advent of kind of soil testing. There's more soil testing happening in Ireland, which are kind of promoting farmers to get soil tested to increase P and K concentrations as well. And with the wind tunnels, we also use the same fertilizers as before, but we also tested a few more compound fertilizer combinations as well. So NPK 10, NPK 24, and also UAN, the liquid version as well. And you'll notice that the IHF we tested on multiple seasons. We actually tested on 3 different seasons, but the actual comparison is only for one. We only did that once, just because of the manpower required. So straight into the results basically. So for the IHF results, this is only IHF. There was no significant results in May 23. Or August 23. The August results I didn't show just because we do need to have a look at those results again. But urea was significantly different from the compound fertilizers in May 24, and we think that the rainfall may have had an impact on the ammonia emissions in May 2023. Which is why we're not seeing those differences. But the May 24 results are kind of what we're expecting. In relation to the weather data, when we do throw everything into a kind of a general linear mixed model, because we're only testing over kind of a certain number of seasons, we do need more data to kind of make this a bit more reliable. Rainfall was the only significant variable, and there was co-linearity between temperature and wind speed. And I think that what this is basically telling us is that we need more diverse spreading periods in our own experiments, basically. So we need to kind of move away from kind of summer and August, but also test colder, cooler, and also higher wind speed seasons as well. And then when we do plug this into the general linear mixed model, the R squared for it is about 0.5. When we move over to the wind tunnels, then we spread in May 2024. We see that urea was significantly different from all the compound fertilizers. UAN wasn't significant compared to urea. So and yes, basically it's a fairly similar story as what you've kind of seen before. The compound fertilizers are much lower compared to urea, which is very, very good. And this is just based on the kind of different ratios of urea to nitrate, the different nitrogen forms within that fertilizer producing that effect. Finally, then with the IHF versus wind tunnels, then this for the kind of one period that we did test them. Wind tunnels underestimated our emissions, and there was higher variability in the wind tunnels, basically. So what we see is that with the IHF and with the wind tunnels, it seemed to be more accurate when there were higher ammonia emissions. However, when we compare it to fertilizers with lower ammonia emissions, they seem to be less accurate as well. They produce greater differences. There were greater differences between the methods when there was lower emissions. And yeah, I just wanted to kind of calculate the kind of airflow as well. I was kind of wondering, was the airflow problem in the wind tunnels during this time, or kind of how steady or kind of comparable was it to the IHF? For the IHF, the kind of average airflow over the period was 3.73 kilometers per hour, so again pretty low. And the airflow in the wind tunnels was about 4 kilometers, so they're pretty kind of spot on an average basis at least, not including gusts. So yeah, there is a bit more tweaking for us to do here, kind of trying to figure this out, how to kind of match the kind of ammonia emission factors that we're going to see, and kind of changing the airflow based on that, I think. So the key findings from what we've seen so far, and again, kind of we are in the early stages of having our own wind tunnels, and kind of and calibrating them and getting them up to date with the IHF method. We see that the wind tunnels underestimated ammonia emission factors, that low emission fertilizers were more problematic for these wind tunnels at least, and that the high emission fertilizers had a higher variation compared to IHF. So for us, further refinement of the wind tunnel method is required. Producing more laminar, trying to produce more laminar flow, I think, as well within the wind tunnel canopy will help quite a bit. And modulation of airflow. There's been quite a few papers on that in the past. I think it's quite a difficult technique to kind of pull off, but there may be some kind of workaround for it. So yeah, I think that's me. Thanks very much to all my co-authors and to the Department of Agriculture for funding the research. And I'll stop sharing now.
Thanks, Sean. Thanks for that very interesting talk. And I'm sure we'll have some good discussion about what you've presented a bit later on. So just reminding people that are listening in, if you have any questions that you'd like to raise, then use the Q&A function, and then we can get to those a bit later on. So our second speaker is Sara Ube. Sara Ube is with INEA in Chile. Sara is a chemist trained in determining greenhouse gas emissions and emission factors. She has supported the implementation of the methodologies in Chile, especially all the analytical techniques associated with emissions. She currently works as a researcher for the National Sustainable Agroecosystems program. Her research focuses on determining the environmental impact of agroecosystems, with a special emphasis on determining greenhouse gas emissions from soils following nitrogen fertilizer application in crops and pastures. She also works on methane from rice cultivation. Sarah is an institutional representative for the GRA in the Croplands Research Group. Over to you, Sarah. Thanks.
Well, thank you, Tony. I will share my screen. Okay. Hello. Today we'll talk about some challenges for nitrous oxide quantification in non-traditional cropping system. This is something that we have been identified in a project. So, this is part of a project, a Fontagro project, optimizing nitrogen use to increase production and reduce environment impact. In this project, we participate 5 countries from Central America and South America, Argentina, Chile, Peru, Panama, and Dominican Republic. And we hope generate emission factors based on the most important locally marketed nitrogen source for each country using common fertilizer those and optimize those. We hope define and evaluate nitrous oxide mitigation strategies for sustainable food production, maintaining or enhancing crop and pasture yield, while reducing greenhouse gas emissions. And of course, we hope contributing to the quantification of national inventories and national carbon neutrality goals. So in each country, we have to decide what kind of system we will use for our experiments. So using our agricultural census, we identify the crop system. In our case, we in Chile is wheat, but mostly is in the central of the country. And in the south, where we are, most part of the land is used for pasture and livestock. Also, use of fertilizers are used, the most amount of fertilizer is used in cereals and also pastures. So, and the source is urea, majorly. So in Chile, for example, we decide to use pasture in our experiment with the nitrogen source as urea. Using the same approximation, each country have a selection. In the case of Argentina, they select maize in 2 experimental sites. One of these close to the coast of the country using a slurry, and the other side using urea in a rain-fed system. And in case of Chile, as I said, we will use pasture with a perennial ryegrass using urea as an end source and in a rain-fed system. In the case of Panama, the crops with more use of urea is a rotation of onion and lettuce. So they will use a raw chicken manure for treat the soil, and then urea with drip irrigation. In the case of Peru, they will study a rotation of potato with lettuce using urea as an end source, and they will irrigate weekly. In Dominican Republic, they will use a permanent pasture with an end source of urea in a rain-fed system. So during this January, we had our first meeting, and we identified some challenges that we have in this project, and I will share with you. First of all, is the technical team of each country, if it's trained or not. So we have different experience. Some countries that have many experience in nitrous oxides emissions determination, but we have another countries with some knowledge, and some countries with non knowledge in the technique. And we know the determination of the greenhouse gas emissions using the static chambers techniques requires that all personnel involved in the experiment understand the importance of the sampling and all complementary parameters such as temperature inside the chambers during the sampling, daily rainfall, daily ambient and soil temperatures, change in the soil nitrogen availability, soil moisture, etc. All these parameters affect the microbiological activity of the soil and therefore nitrous oxide emission. This is a picture from the workshop that we had. They come 2 people from each country, and we have a different level of knowledge about the technique. So we think this could be a challenge in the implementation of the technique. The other challenge that we identify was the standardized sampling frequency, for example. We have many experience in rain-fed system. The sampling frequency we have it was very in agree with other countries. For example, for the week 1, we have a measure the data the date of application before and after, and then 3 days after application at least. Week 2 and 3 times per week. Week 4 to 6 2 times per week, and from the week 6 to the end of the experiment, at least 1 time per week. And that was very clear. The problem was what we're going to do with the irrigated systems. We know that the soil moisture change in the soil can have an implication in the microbiological activity. And then if we have an irrigation every week, we should measure like a first week, like almost every day. And this is very hard, especially for countries that doesn't have many experience in the technique, and it have a lot of cost too. So we decide to, when we have high changes in moisture greater than 20%, for example, from the first days, from with a frequency higher, like first week, or at least like week 2, 3 times per week. But if we have a minor moisture changes less than 20%, we could try to do a sampling frequency like similar to a rainfed system. We still don't know if it is going to work. We have to see during the time, and with the sensors for soil moistures to be checking every day the moisture of the soil, because it's also an influence of the climate of every system. Another challenge that we identified was the quantification of the greenhouse gases. Only 2 countries of the project have a laboratory with a technique implemented and validated for nitrous oxides. And also 1 country is in the process to setting up a similar system, but with manual injection. And for nitrous oxide, we usually produce a lot of samples, around 1,000 of samples, and maybe this could be have some delays during analysis. And we have 2 countries that do not have in-country facilities to measure nitrous oxide. And also these 2 countries they don't.
Oh, we've just got Sarah a little bit frozen there. Hopefully that'll come right very shortly.
Okay.
Okay. They will send their South America with a high risk of siles during the transport and larger delays. We still have some question in this project if will a greenhouse gas workshop be enough for the implementation of the technique in these countries that have never measured it. Can we consider only soil moisture as an event that affects microbiological activity? Maybe we need to validate this for different climates or different seasons. We don't know. And how can we correct the bias of greenhouse gas quantification? This is a challenge, especially in countries that have big delays in analytical determination. Maybe we could use a correction with an external standard or internal standard. We don't know. This project have a lot of importance for our countries. We expect that the result of this project will strengthen technical capacities in participant countries. The project generate a common work protocol based on the international guidelines, in addition of the exchange of experience among the countries participating in the project, contributing to capacity building. The project will generate country-specific emission factors in key categories for the respective national inventories, and the project will contribute to the test mitigation strategy with high potential for adoption by our farmers. And also we will generate, or at least we expect, generate scientific information that will contribute to future research. This is the team in Chile. Thank you very much.
Thank you, Sarah. You shared a very challenging project with us. Very interesting. We nearly lost you at one point. You froze briefly, and but you came back. So that was great that you came back. I don't think we missed too much detail in terms of your presentation. No problem. It was only like for a few seconds. But yeah, thank you for your presentation. We will, if we have any questions around Sarah's presentation, please share them in the Q&A function.
Sorry.
No, don't be sorry. It was fantastic. It's really good, very informative. Okay, so now we're going to move to our third speaker. So I think when this webinar was advertised, we only talked about...
I think I don't have a good signal.
That's what we thought. There's a few things that could probably just buy.
Right, that's okay, Sarah, all good. So when the webinar was advertised, we shared the titles of Sean and Sarah's talks. We do have a third talk that's coming from Marta, who's going to provide an overview of the nitrogen flagship advances and next steps. So just a short blurb around Marta. I'm sure most of you know her, but I'll just share some information in case you don't. So Marta is a senior scientist with AgResearch. She's previously with INEA in Chile, soil scientist by training, with a focus on nitrogen cycling and gaseous emissions. I also know that she's a very active technical expert with the IPCC in terms of the methodologies and I think country expert review teams as well. I think that's right. And she also, importantly, co-leads this nitrogen flagship on nitrogen fertilizers with me. So over to you, Marta.
Thank you, Tony. Good morning, colleagues from New Zealand. Thank you for joining us today. I will share my slides now. Could you please confirm you see everything correctly there?
Yeah, I think you're right.
Not yet. I see you.
So actually, we're not going to buy from you anymore. And then because he was sitting on our list of vendors that we've got.
I'll try again.
I'll just wait.
No, not yet.
James, because I don't really.
There?
Yes, that's good. Thanks.
Yeah.
Thank you. There is a microphone open in the background. I'm not sure where it is. Thank you. Thank you for joining us this morning. As Tony was explaining, we both co-lead this nitrogen flagship for the development of context-specific emission factors following the application of nitrogen fertilizers globally. This flagship was approved by the GRA Council a couple of years ago now. The main issue we would like to address is the high uncertainty in relation to nitrous oxide emission factors following the application of nitrogen fertilizers. As we are all aware, this emission factor 1, as it is known within the IPCC methodological guidelines, is quite variable, and currently, as per inventory reporting, it doesn't reflect the variations in different agricultural systems beyond the variations in nitrogen fertilizer. And that's the main aim of our project. Of course, this work will have implications for the emission factors associated to nitrogen leaching losses and ammonia volatilization as well. So at the moment, we believe there is a low accuracy in general when reporting emissions of nitrous oxide following a nitrogen fertilizer application globally. That's why the aim of this project is to compile all the information we can find available globally in relation to the work you are all doing associated to emission factor development when using nitrogen fertilizers, as well as carrying out new experiments to fill the gaps as much as we can. And the intention is to develop more comprehensive emission factors that will better represent the natural variability of agricultural ecosystems globally, and for those emission factors to be used by parties when reporting emissions of nitrous oxide in their own national inventories. The project is organized in 3 phases. Currently, we're working in phase 1, which it includes the expansion of an existing database, a dataman database, to include emission factor from the use of nitrogen fertilizers. The phase 2 is to develop protocol and guidelines to a little bit align with the presentation that Sean provided today in relation to compare different methodologies and understand the benefits or limitations when using any of those methodologies. And finally, we would like to test new mitigation options, new fertilizer options available globally, and to develop this tier 2 or tier 2 plus, as we say, emissions factor for nitrous oxide emissions. Our intention is to make as much information as possible to be public, to be available publicly as per the database, for instance, also to incorporate new working teams in new grants, and to, of course, to produce general knowledge and scientific publications. As part of the work we have been doing over these last 2 years, the initial database has been expanded, and over 700 emission factors that have been collected, and we will continue this work in the next few months. The nitrogen flagship is composed by 2 what we call pillar projects, which are main projects sustaining the work we are doing. One project is based in Europe. It's called REFIR, and it's a collaboration between the Irish and the New Zealand team. And the other project is the Fontagro project that Sarah has previously presented. So these projects started working and have different objectives, but they both align with the contribution that our nitrogen flagship would like to make over time. As per today, the initial European-based project has, as I was mentioning before, collected information for the development of tier 2 emission factors within this expanded database. At the moment, is making a special effort in incorporating information from other countries, not only from New Zealand and from Ireland. And so if you have information available of work being done in other areas of the globe, please reach out. We are keen to incorporate as much information as we can. The next phase in this project is associated to modeling and comparing the outputs of these models, particularly upstream in New Zealand, with measured data. And further other models will be included in the analysis, including DCD and DayCent. For the 2025 season, we are planning the field experiments, incorporating different fertilizers that you can see there, urea and calcium ammonium nitrate sources, as well as testing a mitigation option, which is inclusion of inhibitor as DCD. In the project by the Latin American team, there was a capacity building, a training activity carried out earlier this year. And the field activities, as Sarah was presenting previously, are planned and will be implemented during this year. In addition, our flagship produces a newsletter, an annual newsletter. You can find that in the GRA website, in the section for our flagship, if you're interested. We have participated in conferences with posters, and we are carrying out these technical webinars that we hope to continue in the near future. We expect our project originally ended, the nitrogen flagship, originally ended in 2027, and we expect there be an extension, or we will request an extension of the project given certain delays in the implementation of both pillar projects at the beginning, as usually happens. So if you are interested in collaborating and participating of these activities, as I was mentioning before, you have historical data that you think it will contribute to this global database, and you would like to be involved, please get in contact. We have the dissemination activities, as I was mentioning, and there'll be more coming up in the next couple of years. If you have expertise you would like to contribute with, either for modeling or data analysis, of course, we are open for that collaboration as well. And if you would like to be involved in new funding collaborative initiatives, this means prepare the proposals and apply for new funding, please get in contact as well. That's from me. I would like to end this presentation thanking the New Zealand government for the support of our activities, as well as thanking the colleagues from the GRA Secretariat for the support they have provided today for this webinar. I will stop sharing. Thank you to our presenters. We will move on now to the QA session. Thank you both, Sean and Sarah, for your very interesting presentations. We already have a couple of questions in the platform. So I think the first question is for Sean in relation to the implementation of the techniques. When you work with wind tunnels, do you usually swap or change canopies during your sampling period?
Yeah, we typically change. We keep the kind of fan body and the canopy kind of together, but then we move it across plots to make sure that the precipitation is as representative of the real world conditions as possible. So we move them over every day. Obviously we'd like to move them over much more frequently, you know, let's say once in the morning, once in the afternoon, just to make sure that the temperature doesn't rise too much. But yeah, again, a kind of manpower is definitely a concern there. So yeah, we move it over once a day, but yeah, that's generally what we do.
Thank you. The presentation came from Chile, from Francisco. We have a second presentation, a second question, not presentation, for Sarah in relation to this comparison across different countries and different, of course, soil types within, and the impact of that could have on your results. So the question comes from Taruvinga. I hope my presentation was correct, my pronunciation was correct. Have you considered the effect of different soil types and textures and the effect that could have on sampling frequency? And if so, how are you accounting for those differences when implementing your experiments?
Thank you for the questions. We actually take account the type of soil and the texture and soil density also, but it's not included precisely in this in the sampling frequency. It's in the could be included in soil moisture as the water-filled pore space. When we are not taking account like a percent of humidity is like the water-filled pore space of the soil. So it depends very much of the density of the soil. I think that is.
Thank you, Sarah. Thank you for your answer. So the point will be, just for my clarification, please. So at the moment you have different soil textures involved within the experiments, and the sampling frequency at the moment has not account for soil texture, but the soil texture through bulk density is included and considered for the estimation later on of the nitrous oxide emissions. Is that correct?
Is that correct? Thank you, Marta. Sorry for my English.
No, it was perfect. Thank you. Thank you for that clarification. We have another question for Sean. It comes from Mart. Sean, do you also compare fertilizers, manure, and soil types using dynamic chambers measurements, or is it focused totally on wind tunnels and IHF? Do you think the dynamic chamber could be could play a role in this sort of experiments?
Yeah, 100%. We have used dynamic chambers in the past, and we kind of moved away from them in this experiment, just to compare the IHF and wind tunnels. But yeah, no, I think they could definitely play a role, obviously depending on which method you use with the dynamic chambers. And again, I think it's more about that the treatment comparison. When it comes to dynamic chambers, the treatment comparison in how do I say it? Increasing your applications and kind of moving through fertilizers, seeing which fertilizers work, and then kind of moving up the stages towards wind tunnels, towards IHF, to actually get kind of an absolute emission factor after that. So yeah, no, we have used them before, but it would certainly be an interesting experiment to kind of compare all of them, and see what kind of results we get with them as well. 100%.
Thank you, Sean. So would you agree that it will depend on the objective of your measurements or the objective of the experiment?
Yeah, absolutely. Absolutely. If you're going to be screening treatments, absolutely. And especially with something like manure treatments, or different synthetic fertilizers. And then once you have your kind of your treatment or your mitigation technique in mind, you can kind of move up towards kind of more absolute techniques then.
Thank you, Sean. We have a new question for Sarah from Pedro. Thank you for your presentation. Have you, in your methodology, considered the changes in nitrous oxide concentration in the sample once taken due to long distance transportation between countries?
Yes, we have not validated something like that. Is something that I don't know if in this project or in a long term, but I think it's in another methodology you can measure recovery of an standard, sometime an internal standard or sometime an external standard. So at this moment, what we have is we are taking a standard external, and we put it in a set of the sampling day, and we recover that standard at the moment of the analysis. But we are not correcting the set of sampling with concentration recovery. So maybe something, I think is something important, especially in our countries where we don't have a laboratory closer, and sometimes we have very long delays from the moment of the sampling to analysis. Try to find a methodology to correct the gas concentration.
Thank you, Sarah. So could you please expand a little bit? So you have seen differences in the analysis of those standards when they are kept long-term with your sampling sets?
Yes, we have seen some difference in some work of validation that we have doing before, sending a standard that we preparate in our laboratory. We send, for example, to UK, and if this go in the lodge, I'm sorry, Martita, ayúdame si no van presurizados en la cabina.
Yeah, if they travel by plane, if they not go in the cabin, they are not pressurized.
Right, you can find big difference. Also, the seal of the vials is also important. So we know that we have seen in sample of standards important difference when we send samples in transportation.
Thank you, Sarah. So maybe replying further to Pedro. So it's not the distance, it's the method of transportation. In this case, it's the long-term, the storage of the samples
Yes.
in the integrated with the method of transportation, because this is airplane transportation, and then there are differences in pressure during that transport. Thank you, Sarah. Are there any more questions from the floor? If you would like to make a comment, maybe, or add a new question in the platform.
I have a question.
Yes, please.
I have a question for Sean. Thanks for the comparison of the IHF and wind tunnels. I'm just thinking, Sean, with respect to the IHF and seeing the image you shared of the 4 slurry strips.
Yeah.
And the need for, I guess, a fetch, a radius that sort of is a known radius. How do you deal with wind direction changes, because you're not getting a perfect circle there? Yeah, how do you deal with that? What happens there with your calculations?
Well, we have the I'm not 100% sure how to answer it. We have the anemometer there. Obviously you taking our samples. And I guess with that field as well, it's a little bit difficult because or it's not difficult, it's a little bit easier because we know the kind of common wind direction, and we're not really going to get wind from the opposite direction, because on the opposite side it's kind of covered by trees. So in that specific experiment, it was either very, very still or it was kind of blowing hard. And obviously with IHF, it works best if it's quite windy, or if it's not still conditions, basically. But we didn't really kind of encounter that problem. I know, and we did try and space out our masts as well to make sure that we weren't getting much contamination, which I know has been a problem before. But I think there's a bit more, again, refinement from our end in terms of contamination as well, based on the wind direction as well. But yeah, in terms of actually kind of dealing with the kind of the wind speed, the wind direction coming from the opposite way, we didn't really encounter that problem in this experiment, to be honest.
Cool, thank you.
Thank you for that question. I got another question for Sarah, if I may. Could you please share with us, Sarah, how are the experiments progressing, if they have been established in Latin America, or what's the status of your fieldwork at the moment?
We are ongoing. We have an experiment established in Argentina, in 2 experimental sites, one in Buenos Aires and another in Córdoba. Also in Peru, they are established the experiment. They will start with the potatoes. In Dominican Republic, I'm sorry. They also are starting in this season. And in Chile, we will start during spring, because we have some problems to implement the experiment during this autumn, and also because during spring is where we use more nitrogen. In the case of the other countries, they also start with the crops with a major requirement of nitrogen. And we hope during spring also start with Panama. That is the country that never have an approximation of the technique, so they will need more support.
Thank you, Sarah. Are there any more questions from the floor? We have a question for Sean from Francisco. Have you compared ammonia losses based on total ammonium content due to the different nitrogen forms when comparing compound fertilizers and urea? Could you comment on that, please?
Yeah. We for this experiment anyway, we only compared based on total nitrogen, or we spread the fertilizers at a rate of 40 kilograms per hectare. So and that was across the board. So on a per kilogram per kilogram nitrogen basis, compound fertilizers were lower. I didn't actually do it on an ammonium basis. Apologies, so that's why I don't have an exact answer for you in regard to that. But I would assume, yeah, if I would assume they'll be fairly similar, to be honest with you. I'm not a synthetic fertilizer expert. Dominica, who might be in the chat, she might have a better answer for you, to be honest, in regard to that. But yeah, no, I'm probably not the best person to ask. And yeah, in regards to Tony's last question, I think I understood his question wrong as well. The shuttles could actually spin as well in relation to the wind, so they could move in relation to wind into the wind direction as well. Just to kind of clarify that.
Thank you, Sean. Given that Sean mentioned Dominica, I don't know, Dominica, if you would like to make a comment in relation to the question by Francisco, maybe leave your thoughts on the chat.
Yeah, I'm here. Sorry, I think, did you guys unmute me? Yeah,
No,
can you hear me?
you are alive. Yeah, we can hear you clearly.
Okay, very good. So I'm not sure if I got the question right, but was Francisco asking about the difference between ammonia emissions being expressed per total nitrogen versus per ammoniacal nitrogen? Yeah, I think that's a very good question. So far we've only looked at total nitrogen because I suppose that was the focus of the project, to see what the emission factor would be from the various fertilizers. With regards to when a farmer applies fertilizer, they are looking at the nitrogen content of that fertilizer and apply on the total nitrogen basis rather than on the ammonium basis. So from that perspective of agricultural practice, we focused on the total nitrogen. But I think it would be really interesting to do a calculation as well on the ammonium basis, because as Francisco rightly pointed out, there is a differential in ammonium content of those fertilizers. And I suppose that's what we're looking at in the LabMag project, but also in another projects, that because of those differentials, whether this is ammonium or nitrate-based fertilizers, the emissions might differ, and we see it very clearly with N2O emissions as well, that we measure as part of the LabMag project. Yeah, so I think this is a good point to kind of to assess the ammonia emissions per ammonium as well, just to see. But that's kind of more, it's more of a scientific concept maybe, as opposed to the agricultural management concept.
Thank you, Dominica, for your explanation.
Thank you.
I don't know if there are any other questions or comments from the floor. There is a question from Terovinga. Do we have collaboration with African institutions in the nitrogen flagship at the moment? And how the emissions result compare so far? And the answer is, we don't know. We have reached out to colleagues in Africa. It hasn't been easy to find information that could be accounted for or included for in the database. We are always open for collaboration. So maybe we could reach out to you after this webinar by email to see what possibilities we could explore together. I don't know, Tony, if you have any other comment on this.
No, I think what you've just said is perfect. I think we need to reach out to Taravinga and see how they can be involved with what we're trying to do here. There's definitely a gap. We do wish to increase the number of data that we're collating for the database for the analysis from African countries, and so yes, very keen to be in touch.
Thank you. Any other thoughts or comments? Any final comments from our keynote speakers, if you wish? No?
I
If
think we're all good.
Yeah, thank you, Sean. Sarah, no?
No, thank you for everything.
Thank you. Thank you both for your very interesting presentations. We are getting close to the time to end our webinar today. I would like to thank again the New Zealand government for the support they provide for the nitrogen flagship co-leading and coordination. Tony and I undertake, as well as our friends from the GRA Secretariat that supported this webinar today. If you are interested in participating in any way possible, look at the GRA website. There is a section for our webinar. The newsletters are there. Our contact details are there. And we'll see you in our next webinar. Thank you very much, everyone, for joining in today. And thank you again to our speakers for the day.